What up, guys? New Build's back in the hood. Thanks for watching my video, Learning with Me Math. So we're going to finish 10.1 today, helping you with a few more of those more difficult problems. Hopefully it's starting to make more sense. If not, keep on watching. You'll get it. Rewatch these videos as much as you need. Just before we do, so I went on a certain game grid, North Ogden, and name that card in the image and get a 5% discount. Don't post the answers, let's make it a little fun. Woo, 5% discount. So I might buy a box of boosters, 5% discounts, you know, a good amount of money. And so I actually took that image and I copied and pasted it, there it is, into Google, and used a reverse image lookup. Didn't know you could do that. So that's something new and cool to show you guys. And so I saved it and reversed image lookup, and it's like, oh, well that's of course the Ravinica Crosstown Courier, because they're going to deliver magic cards to my house since we can't go out of house. And so I double checked that with the website, and I was right, Crosstown Courier. So I'm going to call them up a little bit and order some cards and get 5% discount. Woo! Nice. Friday Night Magic is online because we can't go there during 2020. We have our pandemic, everyone stay at home and play Magic Card Tournament online. So that's what I've been doing. Okay, so then we added a few more since last time because I went ahead and did problem 16 and found out that we do not multiply the powers, no. When combining base powers, so when combining bases, we have to add the powers. So that's something new. That's a new rule from last video. And then also, really, we should talk about rule number 6 as well, which is also plugging it in. And just to make sure you get your answers correct, right? So that's new as well. And so we'll just try that with number 1. So number 1, if you recall, on our last video, we got rid of the bases and divided by -2 to both sides. So that became a... No, we added 2 to the other side, and then we divided by 4. And we got r equals 0. And so let's go ahead and show you and prove that that works. So now we're going to go ahead and plug back in our answer. So if we plug in 0 for r there, and plug in 0 for r there, then let's see here. That's going to be 2 to the -2 to the 0 power equals 2 to the power of 2 and times 0. So basically we plugged in 0 here and 0 here. And then -2 times 0 is just 0. So we end up with also +2 times 0 is 0. And so 2 to the 0 power equals 2 to the 0 power works. And also anything to the 0 power is just 1. So now we know it definitely works. R equals 0 is our correct answer for number 1. Cool. So then we're going to show you how to do some with fractions, right? Fractions. And so maybe we'll start with number 9, and then you could try number 4, or maybe number 3 actually, and then you could try number 5. That's a good idea. Okay. So basically, let's talk about negatives first because that's important. And so with negatives, the negative power either is going to bring it up to the top or down to the bottom. Just depends on where the negative is. So I guess you could call this number 7. And so it's just something you need to know or should have known from last year. So for example, number 3, let's ignore the a for now and just do 4. What in the heck is 4 to the -2? That's the question at hand. So what is 4 to the -2? Well, basically, the negative is going to go ahead. So this would be 4 to the -2 over 1. And so basically the 4 then is going to come down here and make it a +2. So we'll have an invisible 1, or just a 1 that stays on top. And then the 4 is going to come down, so 4. And then instead of -2 now, it'll be a +2. Or just 4 squared. And so that means that's going to be 1 over 4 squared, which is just 1 over 16. So we just learned that 4 to the -2 is going to be 1 over 16. Nice. Awesome. So then for this particular problem, we want to we want to probably do that and just see what we get here. And so let's kind of start this problem off by bringing that 4 down below. And so that negative is going to bring the whole thing down. So then we're going to have 1 over 4 to the positive 2a now. There we go. And then that's going to equal 1 over 64. Still trying to figure out what this is. We're getting closer though. So now if you think about it, we could kind of ignore the ones on top for now and just solve, right? How is this going to equal 64? That's a way we could do it. There's lots of different ways to solve these problems. But if we could just get them to both equal 64 on the left and the right and the bottom and the denominator, then we've got it made. So maybe we'll kind of think about it that way, right? That's a good idea, huh? Cool. So then, let's see here. So now let's just kind of work with the bottom for a little bit now. So now we want to go ahead and get 64 to look like 4, get a base of 4, just like we learned before. So now we're going to take this problem, if we're showing all our steps here, there we go. So what does 64 break down into? Well, 8 times 8 is 64, cool. But that's still not a base of 4 yet, right? We want a base of 4 is what we want. And so, well, 8 breaks down into 2 times 4 and 2 times 4. Cool. Well, that's going too far now. That's in the bases of 2. So can we multiply those together? We sure can. And so 2 times 2 is 4. So now we can know that 64 is the same as 4 times 4 times 4. And that's our base of 4. Cool. And let's double check that. So 4 times 4 times 4. Oops. We forgot our last 4. So 4 times 4 times 4 is 64. Or in other words, 4 to the third power is 64. So that's what we're going to use now, is that. So this is just some notes here. There we go. Okay, so then, let's see here. So then we're going to go ahead and break down 64 there. So now we have 1 over 4, still 2 to the a power. But this time, we're going to have that equal to 1 over 4 times 4 times 4, or to the third power. Nice. Okay, so now basically we're just trying to figure out, we're still doing the ones there, it's still fractions, but we're just looking at the bottom how they could exactly equal each other. And this is just one method how to do this. We'll show you the other method in a second as well. Okay, so 4 to the 2a, we're just going to set that equal to 4 to the third power. And now we can log base 4, and get rid of our 4's. So how does 2a equal 3? Well, right now, 2 is being times with the a, so we'll just divide by 2, divide by 2. Cool. So now we get 3 halves, or 1.5. The a's cancel. That's what a equals, and that's our answer. And that's our answer. Nice. Nice, nice, nice. So that's our answer there. So then, cool. So then if we plug that back in, let's use a different color now. Because remember rule number 6, you want to go ahead and plug it back into your answer to make sure it works. So if we plug back in for a 3 halves, well, 3 halves times 2, the 2's will cancel, and it's just 4 to the third power. And 4 to the third power is 64, so it works. So our answer is 3 halves. We'll double check there for number 3. And so number 3, our answer is 3 halves. We got it. Nice. Okay, there we go. So that's kind of one way to do fractions. Looking at another way to do fractions. Let's see here. So for example, number 9, that's a good one to kind of think about or look at. And so number 9, we remember that the negative kind of flips it. Okay, so If we had a negative 1 down here, for example, then that would send the 4 up to the top and make it a whole number. And so this is a kind of another way to do these problems. And so what I'm saying here is if we did a negative 1 to the top and the bottom, then that's just going to flip it. Let's see, just thinking about how we could get to that 1/4 to some power is going to equal 16, right? Cool. Well, right now it's a fraction, so how do we make it not a fraction? Well, this is kind of a guess and check is the method I'm doing on this one now. And so 1/4 to the what power, right, is going to make it into a whole number. Well, I know that if b is like a negative 1, then like this, then I would distribute that through, and that would actually flip it. Flip it. And so then that would become 4 to the positive 1. And so 4 to the positive 1 is almost 16. So then what would b need to be to make it a 16? Well, if b is a 2, if it's b is a 2, then that would make it 4 squared, and 4 times 4 is equal to 16. Wow, so this is kind of guess and checking, kind of a weird way to do this problem, but that would definitely work. So not only do we need our b, not only do we need our b to be a negative 1, but also a 2, right? So that's kind of what's going on there. So if we think about that in this way, this is kind of a very guess and check way to do this type of problem. But there's lots of ways to do these problems, lots of different ways. And this is just one way that just comes to my mind, is just thinking about how that would become a 16. Awesome. So now if I erase this and guess and check and see if this works. So now if b is not just a negative 1, but a negative 2, well then that means it's going to bring the 4 up to the top, and then also it's going to make it squared. So let's just check our work and see if that works. So we have 1, so parenthesis 1 divided by 4 to the, and then negative 2 power, because that'll make it a positive 4 squared, which should be 16. It worked! It worked, it worked, it worked. We checked it, it worked. Nice. So then we'll go back here, and voila. Kind of showing our work there, right? Showing our work there. So then we show our work there, and so it works. 1/4 to the, where b is negative 2, that's going to give us 16. So if you wanted to do it the regular solving method that I taught you in the first video, you'd have to do some manipulating for sure. You'd have to, let's see, you'd have to raise it to the negative 1 power and do both sides like that and solve it. So kind of thinking of that, let's do an easy one and then we'll finish off 13. So 16 looks kind of easy. It does have a little bit of trick to it though. So I learned from number 16 that when combining bases you have to add the powers, not multiplying. So I made a mistake there and had to redo this video, but that's okay, everybody makes mistakes. Everybody has those days. So for example 16, so 36 breaks down into 6 times 6, which is the same as 6 squared. So that's what I turn 36 into. This is more like the first video. And then times, and then we have 6 to the 3k power, nice, equals 6 to the 2 minus 2k power. So what we're trying to do now is get the same base. And so I turn 36 into 6 squared because now we have the same base as 6's. But now when you combine your bases, you have to add the powers. So now we're going to get 6 to the 3k, and then plus 2 is equal to 6 to the 2 minus 2k. Right? Nice. And now we have our same base. And now we can eliminate our bases by log basing 6 both sides. That gets rid of, again, our bases. And now we can just solve for the exponents. So 3k plus 2 is equal to 2 minus 2k. And now we're going to solve for k. So we want to get everything on the same side. So the opposite of negative 2k is positive 2k. So we're going to add 2k over to here. And then 3k plus 2k is 5k. And then plus 2 is equal to, whoa, is equal to 2. That 2 is still there. We're going to bring that down. Those are going to match and do something weird. So we're going to minus 2 to both sides. And that makes it 0. So now we have 5k is equal to 0. And then we'll divide by 5 and divide by 5 to solve for k, because right now it's being multiplied. So we'll divide it. And so then that's going to be 0 divided by 5 is just 0. So k is equal to 0. And then we can plug it back in, make sure it works. And so 3 times 0 is just 0. And so 6 to the 0 power is just a 1. And 1 times anything is just 36. Equals, on this side we plug in the k equals 0. Negative 2 times 0 is just 0, so this just goes away. And yep, 6 squared is 36, so it works. So that's our answer for 16. So the key we learned there was that when you combine your bases, the 6 and the 6, you have to add those powers and not multiply them. That's where I made a mistake. So add the powers, exponent, add the powers. We're going to do an exponent with an exponent. Okay, so then number 13 was a super tricky one. And but I discovered a faster way to do this is to keep the 81s on top. So all we're going to do is take this 9 to the negative 2b power, and we're going to bring it up here and make it a positive 2b power, right? So now we have 9 to the positive 2b power times 81 to the negative b, which we could bring, that negative means to bring it back down to the bottom, but we're going to keep it there for now because we don't like to have fractions when we're doing these if possible. Okay, so now we can combine some stuff here. So for example, this is 9 to b, and then 81 to the negative b, so 81 can now break down into 9 times 9, right? Because 9 times 9 is 81. And then we can break that down into 9 squared. Now don't forget that the negative b was also in there, and so we do have to multiply with that negative b. Cool. So now we'll bring this down. So we have our original 9 2b. Then we have times our 9, which originally was 81 but became 9 squared. And then 9 squared, but we have a 2 with a negative b. You do have to multiply those because we're not combining bases. They're just next to each other, which means to multiply. So that's going to be 9 to the negative 2b. Equals 81. Nice, nice. Tricky one. And then now we're going to combine our bases and add those powers. So now it's going to be 9 to the 2b plus a negative 2b. And so 2b or not 2b is the question. New bold. So then we're going to go ahead and combine those, and what the 2b minus 2b is 0. It just goes away. So now we have 9 to the 0 is equal to 81. What the 9 to the 0 power is just 1. And 1 does not equal, because that's supposed to be just a 0 now, because these canceled. And so 1 does not equal 81. So I'm glad I did number 13 with you, because that was a no solution one. Very silly, but definitely a no solution one. And silly, silly. So you go ahead and try the other ones. And email me if you have any questions. But we did 1, 2, 3, 4, 5, 6, 7 of them out of 18. So you only have 11 problems or so to do, which isn't too bad for this week, right? 11 problems, not too bad. So thanks for watching, and I appreciate you. And so email me if you have questions. I'll do another video on more problems if you need. So thanks for watching. Make sure to stay in your home, right? Stay in your home. Stay in the hood. Stay in the hood. Stay in your home. Stay safe. Stay safe. Peace out. Thanks for watching. Bye for now.